question might have been graph y equals x squared plus 6x plus 7. First off, that is not a line. How do you know that it's not a line? It's got an exponent. It's got an x squared. So our technique for graphing these, what we talked about the other day, we built ourselves a table. And we plugged a number in. What number did we plug in? We plugged in 7, but we did an unusual thing. We plugged it in for the y number. And what's going to happen when we plug 7 in for the y number, we're going to end up with 2 answers for x. Okay, so I'm going to plug 7 in. I get 7 equals x squared plus 6x plus 7. How do you solve that equation? Subtract 7. So you have 0 equals x squared plus 6x. Then what?
0 equals x. And then the parentheses x plus 7.
Excellent. We factor the right-hand side, and we factor out the GCF. The GCF happens to be an x.
Did we went over this in class? I thought we only went over the plugged in for x.
No, this is what we were doing near the end of class on Friday. So we ended up with 2 answers, x equals 0, x plus 6 equals 0. So the first one's already done. X is already by itself. We have x equals 0. The second one, we subtract the 6 on both sides. We get x equals negative 6. So we can come back here and we plug in 0, and we plug in negative 6. Those are our 2 x numbers. Now, the most important point on this graph has a name because it's got an x squared. It's called a parabola. The most important point on this graph is the vertex. How do we now find the vertex? It's halfway in between these 2 numbers. So what's halfway in between 0 and negative 6? Negative 3. So our vertex is going to happen at negative 3. I take negative 3 and I plug it in. That's going to be negative 3 squared plus 6 times negative 3 plus 7. Negative 3 squared is minus 18 plus 7. 9 minus 18 is negative 9. Negative 9 plus 7, negative 2. So our graph would look like this. We have the vertex at negative 3, negative 2. Is that vertex going to be the highest point on the graph, or is it going to be the lowest point on the graph?
The highest.
No, it's going to be the lowest. How do we know it's the lowest? It could be a negative y and still be the highest.
Well, compared to the other 2.
Compared to the other 2, it's definitely lower. What I was looking for is this first number right here is a positive number. It's the number 1. When this first number is positive, the parabola goes up. So the vertex is the lowest point. If this first number were a negative, then the parabola would have to go that way, and the vertex would be the high point. Or, of course, the other answer is we know we have to have 0, 7, and we know we have to have negative 6, 7. So clearly that vertex is a low point. We draw a nice smooth curve to our points. And there's our picture. Questions on that?
So the vertex would be negative 3, negative 2?
Correct. The vertex would be negative 3, negative 2.
Okay, and just one more question. This is probably stupid, but I'm just wondering, like, how you got that x equals 0, and like, did you just solve those?
Yes, I just solved these. I solved these 2. Absolutely.
But I mean, like, where did the x equals 0 come from?
I have 2 things multiplied together equal to 0. How can you multiply 2 numbers together and get an answer of 0? One of them has to be 0. So the first one might be 0, which the first one is just the letter x. So x could be 0, or x plus 6 could be 0. When you do this technique, when you take your equation and you set it equal to this number, one of your answers will always be 0. Always, always, always. Other questions? Now, Brett must have read the book, because we hadn't talked about this on Friday. He mentioned that there's a handy little formula that you could also use for finding the vertex. What was that handy little formula?
Negative b over 2a.
All right, so a handy little formula for finding the vertex. It gives you the x number. X equals negative b, I don't want to write it that way, negative b over 2a. Where what's b and what's a?
The exponent is squared is a, the a x2, and then plus bx plus c. Right?
Okay, so typically we write our equation this way. Y equals ax squared plus bx plus c. So a is the number, it's the coefficient in front of the x squared. B is the coefficient of the x, and c is just the constant. Okay, so another option would be, I might say, graph y equals, how about negative 2x squared plus 4x plus 3. And if I ask you to graph this, minimal thing I would expect to see is I would expect that you're going to give me the vertex, because that's always the most important point. And then I would expect you would give me at least 1 point on each side of the vertex. You can give me more if you want, of course. So you really have two choices. Choice number 1 is take this equation, set it equal to
0.
not 0,
3.
equal to 3, whatever this number is here, and solve. And that would give you a couple points. Another option for finding the vertex is to just use the little formula. X equals negative b over 2a. In this case, what's negative b? Bless you.
4.
B is the number 4, so negative b will be negative 4, divided by, what's the a number? Negative 2. What's 2 times negative 2? Negative 4. And negative 4 divided by negative 4 is 1. But that's only half the answer. What do I mean that's only half the answer? I got to have the y number also. How do I find the y number? Plug it in. So I'm going to plug in 1. Y equals negative 2 times 1 squared plus 4 times 1 plus 3. That's negative 2 plus 4, which is 2. And then 2 plus 3 is 5. All right, so I can start drawing my graph. I've got my vertex right here at 1, 5.
Isn't that more work than the other one? This one seems like more work than the other way.
Yeah, I agree.
Yeah.
And I'm confused as to where some of the numbers came from too.
Yeah, so I'm
Like
Yeah.
the negative 2 point, or negative 2 times 1, I get where the negative 2 came from. Plus 4. 4 came from where?
4 times 1. The 4 is here. I just plugged 1 in.
Oh, and then the 1 is what you got, and the 3
Yep.
is the y.
How did you get the negative 4 divided by negative 4?
I used my little formula, negative b over 2a.
Yeah.
So this is my a number, this is my b number, and this is my c number.
Okay.
So b is the number 4. So negative b would be negative 4. And then 2 times a is the number negative 2. So 2 times negative 2 is
Negative.
negative 4. Now, keep in mind that the other way that we did it, eventually I would have to take that number 1 and plug it in anyway, wouldn't I? So all this work is really the same work that I would have to do if I did it the other way. So which way is easier? I don't know. Whichever way you like better.
And it's always going to be in that order, A, B, C?
It's always in the order A, B, C. Correct. Math people like to put things in alphabetical order. A, B, C. Yep. Yeah, we're very alphabetical. All right, now what I would need to do is I would need to build a little table and plug some numbers in. So I would probably pick my favorite number in the whole wide world for x,
0.
which is 0. If I plug 0 in, what do I get for an answer?
8.
3, because if I plug 0 in, this is going to be 0. That's going to be 0. The only thing left is 3. So I would have the point 0, 3. Without doing any work at all, you should be able to tell me what that point is right there. 2, 3. Why does that have to be 2, 3?
Or what's the other half?
It's the other half of the parabola. That's correct. If the y numbers are going to be the same, then the x numbers have to be related. To get a y value of 3, I had to go one step to the left. So to get a y value of 3, I also have to go one step to the right. So that's the advantage of doing it this way. The advantage of doing it this way is you can always plug in 0 and get 1 point. And then in a sense, if you use the symmetry property, you get the other one for free without having to do any work.
So if you come up with
There's my graph.
I see the relate like 0, 1, 2. I see how it's going.
Yep.
So for fun, because you don't want that table to look so empty, can we put 1, 5, and 2, 3 over there?
Sure.
It wouldn't hurt, right?
Nope, doesn't hurt at all. Just fill them in if you wish. Okay, so let's take a look at number 5. Number 5 says, find the x-intercepts and the y-intercept. Next, find the vertex. And then when you get all done that, draw me a pretty picture. How do you find the x-intercept?
Plug in numbers, whatever you want, right? For
No, you plug in a very special number.
10.
You plug in 0 to find the x-intercept. You always plug 0 in for which letter? Y. If I ask you to find the x-intercept,
Oh, okay.
that means you're plugging 0 in for the other letter. So to find the x-intercepts, we plug 0 in for y. So we're going to have 0 equals 5x squared minus 10x. How would you solve that equation? Factor it. How would you factor it?
Take a 5x out.
Take a GCF of 5x. Excellent. 0 equals 5x times x minus 2. That's going to give me 5x equals 0 or x minus 2 equals 0. What do I get for my two answers?
0 and 2.
X equals 0, x equals 2. All right, so I can draw those dots. I have 0, 0, and I have 2, 0. Now you're telling me, without thinking hard and without doing much work, that my vertex has to happen at x equals 1. And you're absolutely right. Why does my vertex have to happen at x equals 1? It's got to be halfway in between. So now you're absolutely right. I'm going to build myself a little table here. And I could write this in my table. I've got 0, 0. I've got 2, 0. And you're telling me I absolutely want to plug in 1, because 1 is where my vertex is going to happen.
Zero.
What's that?
How did you get the 0 for y?
Because that's the number I plugged in for y, didn't I?
Uh-uh.
I plugged in 0 for y right from the beginning. To find my x-intercepts, I always plug 0 in for y. Okay, if I plug in 1, I'm going to have 5 minus 10, which is negative 5. So I've got the point 1, negative 5. That's right there. So it said find the x-intercepts. I did that. It said find the y-intercept. I skipped that for a minute. I went right to the vertex. I found my vertex. How do I find the y-intercept? Plug what in?
0
Plug 0 in for x. Mike?
why did you do 5 minus 10?
Because I plugged 1 in. What's 1 squared? I plug.
1 squared.
I'm plugging 1 in. What's 1 squared? What's 1 times 5? 5. And then I plug 1 in here. 1 times 10 is 10. So it's just 5 minus 10. All right, so once again, the last thing we have left to do is find our y-intercept. How do I find my y-intercept again? Plug 0 in for x, but I already have that, don't I? Didn't I already plug 0 in for x? Yeah, so that one happens to be an x-intercept and a y-intercept. We already found the y-intercept by accident.
And that's okay?
That's okay. That can happen. It doesn't usually happen, but it can happen. All right, so there's our picture. We connect the dots. Nice smooth curve. There's our parabola.
So the vertex is 1, -5.
The vertex is 1, -5, correct.
And the y-intercept is 0,
The y-intercept is 0, 0,
and the x-intercept is 0, 0.
and the other x-intercept is 2, 0. There were 2 x-intercepts, right? There are 2 spots where it hits the x-axis. There are 2 x-intercepts. All right, let's try B. This time, let's find the y-intercept first. Usually, finding the y-intercept is pretty much the easiest thing to do. How do you find the y-intercept?
C number, right?
Plug 0 in for x, and you're absolutely right, it's going to turn out to be the C number. Because when I plug 0 in, what's 0 squared?
0.
What's 10 times 0?
0.
What's 0 plus 0 plus 24?
24.
24. So Brett is right. This number on the end, this 24, this C number is always the y-intercept. Personally, I just like to remember plug 0 in for x because that's what we've always done. All right, that's y-intercept. X-intercept, how do you find the x-intercept?
Plug 0 for y.
Plug 0 for y. So we're going to have 0 equals x squared minus 10x plus 24. How do you solve that equation? You factor. Can you factor x squared minus 10x plus 24?
Yes. 12 and 2.
12 and 2?
Or 12 and or -12, +2.
All right. -12 and +2. Unfortunately, I think that's the wrong answer. Why?
It would be a -24.
Because a -12 times a +2 would give me a -24. It does give me the -10 in the middle, but it doesn't give me the 24 on the end. So watch for that. You got to make both your signs work. That one didn't work, so we try again.
Aren't they all different?
Subtract 24.
No, I don't want to subtract 24.
Why not?
Why not?
Factor x minus 6x minus 4.
We want to factor it directly the way it is. It's absolutely critical that we have 0 on one side. Why is it absolutely critical that we have 0 on one side and we don't want to move the 24 over to the other side? How do you multiply two things together and get an answer of 0? One of them has to be 0. If I move the 24 over, how do you multiply two things together and get an answer of 24? There's lots and lots and lots of ways, aren't there? All right, so when we are solving quadratic equations, when we have an equation with an x squared in it, it's absolutely imperative that we have 0 on one side. Always got to have 0 on one side. Because we want to use that special 0 multiplication property that says x minus 6 has to be 0 or x minus 4 has to be 0. Which means x is, or x is 4. So that gives me 2 more points. 6, 0, and 4, 0. So far I have 0, 24, which is right there. I have 4, 0, and I have 6, 0. Where does my vertex have to sit? Where? It's got to sit below. That's true.
Oh, it has to be at 5, isn't
It has to be at x equals 5. Absolutely. Why does it have to be at x equals 5? Because that's got to be directly in between these two. These two are at the same height. So the vertex has to be right in the middle, and that's at x equals 5. What do I do with that x equals 5? Plug it in where? Up into my equation. So I plug 5 in. What's 5 squared? 25. Minus, what's 10 times 5? 50 plus 24. 25 minus 50 is negative 25. Negative 25 plus 24? Negative 1. So my vertex is 5, negative 1. Right there.
I did the same thing somehow. I got the same thing, but I just didn't have 6 and 0 and 4 and 0. When I plugged 24 in for 0, I did that one.
Yeah, that's how I did it. But it was just because we were finding the vertex and not all of the y-intercepts and x-intercepts.
When I said it earlier, you said not to do that, but that's what I did, and that's what I got.
So you were answering this question a different way. So let me do this question again, the way you were doing it. Here was her way. Same exact problem. You decided you wanted to find the vertex. Our technique in the past for finding the vertex was we took x squared minus 10x plus 24, and we set it equal to (24), whatever this number was.
Yeah, that's what I did.
Okay. So if I set it equal to this number, then I absolutely, completely agree with you that you better subtract the 24.
Yeah, that's what I was talking about.
Why do you have to subtract the 24?
To make it 0.
To make it 0. So you have x squared minus 10x equals 0. So you have x times x minus 10 equals 0. That gives you two answers. Your two answers are x equals 0 and x equals 10. So what do you have at this point? You have 0, comma 24, and you have 10, 24.
Yeah.
All right, so you have 0, 24 and 10, 24. So where does the vertex have to be?
Well, I flipped it right now.
Right in the middle, doesn't it? Since these are at the same height, the vertex would have to be right in the middle. Halfway between 0 and 10 is 5. You plug 5 in, you should get negative 1 again. You should get the same answer. So you would have that, which is good. And you could draw the picture, but the problem is you haven't quite answered all the questions. The questions were find the vertex, what you did, find the y-intercept, what you did. You haven't found the x-intercepts yet, though. So what would you have to do to find the x-intercepts?
Do halfway in between again?
No. To find the x-intercepts, you have to plug 0 in for the y number, which is the way we did it. So notice
Did it backwards.
Notice that by finding the x-intercepts, you get 2 points that you can use to find the vertex. Now, the bad news is, and the reason we show both ways, is do these things always factor? No. So if these things don't factor, we wouldn't be able to find the x-intercepts. And if we can't find the x-intercepts, then to find the vertex, we would absolutely have to go back and do it this way. So in most cases, I would say this is the better way to do it, because you're guaranteed that this way is always going to work. Finding the x-intercepts won't always work. Sometimes those things are prime. Other questions? All right. Now look what we have. Exciting word problems. I know, contain your excitement, huh? It says a batter hits a baseball. The ball's height in feet, h of t, after t seconds is given by h of t equals minus 16t squared plus 140t plus 3. What is the ball's height when the batter makes contact with it? No, it wouldn't be the vertex.
You plug in 0 for t.
You'd plug in 0 for t. Why would you plug in 0 for t?
Because my answer says 0 seconds.
When he hits it, that's right when we're starting, that's t equals 0 seconds. So for part A, we want to plug in 0 for t. If we plug in 0 for t, how high up in the air is the ball? 3 feet. So the ball starts 3 feet in the air. And then what happens? The ball goes up, and eventually it comes back down. Okay. What is the maximum height of the ball? When does it reach that height? What's another word for maximum height of the ball? Another word for that is the vertex. The ball goes up, it comes back down. Where's the maximum? The maximum is right at the vertex. So this is a fancy way of saying find the vertex. Okay. How would you find the vertex? Not plug in 3 for each of the t's.
For h of t.
Oh, for h of t. Okay, I misheard you. Yes, absolutely. We're going to take this number and we're going to plug it in for h. So we're going to have 3 equals minus 16t squared plus 140t plus 3. We subtract 3 on both sides. Why do we subtract 3 on both sides? To get 0 on one side. 0 equals minus 16t squared plus 140t. Can you factor? Yes.
T, 16t minus 140.
What's that?
Plus t and then in parentheses 16t minus 140.
Okay, that'll work. 0 equals t times minus 16t plus 140.
No, negative t, and then it's negative 140. I just realized that. Because it's negative 16t squared.
Oh,
So I said negative t, and then in parentheses 16t minus 140.
Okay, so another correct answer would be negative t times 16t minus 140. And that's what we normally do. Normally when we have a negative here, we factor out a negative. So either of those would be correct.
I factored
How did you factor yours?
4 goes in the
Okay, so Cassandra did not use the greatest common factor. She just took out a t. You could do even better, and you could take out a negative 4t. All right, so we could also factor it this way: negative 4t times what would be left over?
4t minus 35.
4t minus 35. Which one's right? All 3 of them are right, and all 3 of them are going to get you the right answer. So this is when you're solving equations, it's not quite as important that you take out the GCF. But it's always a good idea to take out the GCF. Like,
So when it says h of t equals whatever, that means that it wants to know what t is.
yes,
Which would basically be what x is.
yes. So compared to what we did before is we said whatever this number is, plug it in for y. But now we're not using the letter y, we're using the letter h. And now we're going to find the t. T is like the letter x from what we did before. Okay, so we have minus 4t equals 0 and 4t minus 35 equals 0. This one, I divide by negative 4, I get t equals 0. This one, how would you solve this one? Add 35 and then divide by 4. And I think it might be a good idea to get a decimal there. How much? 8.75. Okay, so here's what we just found out. If I plug in 3 for my h number, I get two answers. I get 0 and I get 8.75. Almost sneezed, but not quite. How does that help us to find our vertex?
In the middle of 0 and 8.
The vertex has to be halfway between 0 and 8.75.
4.375.
So you take 8.75 and you divide it by 2, and I agree, you get 4.375.
I got that same answer, but I got it negative because at first I started with the formula for vertex,
Okay,
and I got negative 4.37.
you should have got positive.
Oh yeah, I did get positive. This is too negative.
Correct. So, if you wanted to use the little formula, you would have t equals negative b over 2a. What's the b number in this problem?
Negative 140.
The b number is 140, so negative b is going to be negative 140. And the a number?
Negative 32.
So I'm going to take 2 times negative 16, that's going to give me negative 32. And if you grab your calculator and you take negative 140 divided by negative 32, you should get exactly 4.375.
So I get that you plugged in 0 for t, that was one of the t's, 0.
Yep.
And then you're going to get 2h's, so you're plugging in twice. The 8.75, that's what it is. What's below that?
4.375.
Oh, that's if you do the formula.
Well, no, or
It's half of it.
it's got to be halfway in between. So I take the 8.75 and I divide it by 2. Now what I need to do is I need to take this number, 4.375, and plug it into this formula, don't I?
So you can get to each.
Right, so I'm just going to use my calculator to do that. Negative 16 times
Really big.
4.375 squared. It's a really big number right here. We'll see. Plus 140 times 4.375. Let's say you didn't square it. I got 309 and a quarter. So what does this mean? What does this vertex, here's our vertex, what does this point tell us about the ball?
So maximum height was 309 feet, 4.375 seconds.
Excellent. The ball's maximum height was 309.25 feet, and that happened after 4.375 seconds. 4.375 seconds after the ball was hit. That's when it reached its maximum. Okay, so the graph. I've got 4.375. There's 3, there's 5. 4.375 would be somewhere in between. And then 309, just a little bit more than 300, right about there. And then I had 0.3. That's right about there, not very high up. And I had 8.753, right about there, yep. So there's my 0.3, and there's my 8.753. And so I draw my picture, and I would draw it like this. Come up, there's my maximum, comes down, and I would stop right there, right where it hits the axis. I wouldn't draw it further down and put an arrow, and I wouldn't draw further down and put an arrow on this side either. Why not? Why do I stop it right when it hits the axis?
Ball can't go down.
That's when the ball hits the ground. Can it go any lower than that? No, it can't go any lower than the ground. This axis here, this is the ground. Ball can't go lower than that. I suppose it could hit and bounce. Do that. How come I don't draw this way and draw an arrow? Because this is where we started. We can't go this way. This would be negative time. I can't go backward in time. So I'm drawing it like that. Questions on that one? All right, this last one. It gives us the picture. And it asks us questions about the picture. It asks us, what are the coordinates of the vertex?
3, -1.
3, -1. Why 3, -1?
Because that's what the picture shows.
That's what the picture shows. The vertex would be the little spot, and it's right there. That's 3, -1. What are the x-intercepts? 2, 0, and 4, 0. Excellent. It crosses the x-axis twice at 2 and 4. What is the y-intercept? Looks like it's right here. Looks like 0, 8. What is y when x equals 6?
8.
How'd you get that?
You go up the 6 on the x, and then where the line touches, you look over at y.
All right, so I go over to where x is 6, and then you said where the line touches. You really didn't mean to use the word line. You meant to use the word parabola. It's definitely not a line, is it? Definitely not a line. And you go up, and it looks like it hits right at 8. I would agree. All right. What is x when y equals 3? There are two answers, aren't there? When y equals 3, x could be the number 1, or x could be the number 5. So x could be 1, x could be 5. There are two answers for that one. Does the function represented by the graph have a maximum or a minimum?
Yes.
Yes. Which one?
Minimum.
It has a minimum. Where's the minimum?
The vertex?
At the vertex. So the answer would be yes. Min at 3, -1. Questions on that? That one was easy, I agree. Let's hope they're all like that.
So I'm going to assume